So I'm Corvin Santo. Um, I work for Portland Labs, the company that is behind Concrete 5. I'm here today to talk about some of the benefits and features that PHP has in terms of object-oriented programming. This talk is directed at somebody who might be familiar with object-oriented programming. You might have seen a class here or there. You might have used the new keyword, and maybe you just cast your arrays to objects and call it object-oriented programming. But this will also be good for somebody who maybe doesn't have any experience at all and just wants to kind of go over the broad concepts. So I'm kind of going to do a high-level overview of the features and not quite something that will get you employable. So let's get started. I want to start with why you should use object-oriented programming. One thing that I think it adds is it lets you add a more meaningful type to your value objects. So think back to a time when you had an array of data, maybe a form submission. It might be something that you're selling that you pull out of the database. In this talk, I'm going to be using the example of a t-shirt store. So we're going to have objects that are t-shirts. So if you think about this array of data that you have, it has attributes to it. So if it's a t-shirt, if it's an array that contains attributes for a t-shirt, it's going to have keys like size, color, description, maybe price. One thing that object-oriented programming lets us do is give these things a more meaningful name or type. We call it a class name. So instead of an array that contains information about a shirt that contains, a key with size, color, and description, we have an actual object that is a t-shirt. It has a color, it has a size. And I think this is a much more healthy way to think about programming. And I think ultimately it's a much easier way to think about programming. Another thing that we get out of object-oriented programming is a way to organize our common functionalities. So instead of something like in PHP, the MySQL module that has all of its function names prepended with MySQL underscore, we can have a single class name, MySQL connection, that has functions underneath it like query and connect instead of MySQL query and MySQL connect. So that lets us group our common functionalities without having to add that MySQL underscore namespace, which is really convenient. The last thing I want to say is that it gives our services state. Service is kind of a word that has a lot of meaning that it's kind of unintuitive. When I say service, an example that you probably have in your code base is session. So your code base has some kind of service that enables session. And what that might be, it might just be like Concrete 5.5 had. It might just be in a long procedural file at the top. We just say session start. And that's your service. It's just a single line of code, but that's the service that manages your session. So when I say that object-oriented programming gives states to your service, extending the session metaphor, instead of just starting your session and hoping that it'll just work globally, what we can do is have an actual session object that keeps track of its own state. So in object-oriented programming, classes are the schematic to the finished building. When I was a kid, I spent a lot of time at one of my friend's house. I remember the layout, it was a very distinct layout. I remember it very distinctly because one year I went to a new friend's house and it was the exact same house. Same layout, same everything, just different couches, different people, different paint. Uh, Imagine classes being the set of instructions that the crew and the foreman use to rebuild that same house. It might have a different coat of paint, but it's still the same house. Uh, Objects are instances of a class. So extending that metaphor, objects are the house. So let's go into an example. This is a class. This is a shirt class. At the very top, we say, we define a class, to give it a name of shirt. And then we define some properties. We'll start with those. Properties are the state of your object. If you think about a real physical shirt, it has a color and a size. So does your object. So um, so that you can store in this, if you have an instance of shirt, you might have two instances of shirt that have different colors, but they're both shirts, and you want to be able to tell that they're both shirts, but you want to be able to see the difference. Um, After that, we have some function declarations. These are just normal PHP functions. They come with some extra stuff called scope that doesn't really matter. If you look at this function, what you see is a variable in here that you don't define. It's called this. This just refers back to the instance of the shirt. So when we say size equals this size, we're referring back to that size property on the instance of our shirt. And the final thing I have in this class is a magic method. You can tell it's super magic because it's got those two underscores in front of it. That's where the magic is. This is a constructor method. It's a method that runs right when your class gets instantiated into an object. So when we create a new object, PHP knows to call this underscore underscore construct and pass in a color and a size. So that way we know that if we have a shirt object, it's always going to have a color and it's always going to have a size because you have to pass these in. So let's look at how we use this object or this class. We have a function here, output shirt. You'll see we have a single parameter, and before it we have the string search or shirt. It's the same string as our class name, and this tells PHP that anytime we get a parameter there, it's going to have to be an object that was made off of the shirt class. So since we know that it's an object made off of the shirt class, we can be sure that there's always going to be a get string function there. So we can say output shirt function, give us a shirt, and we'll get the shirt string and just echo it out. So then now we create a new shirt instance. We say shirt equals new shirt. It looks a lot like a function call, and it really is. We're just saying shirt with two parameters, but PHP sees this new keyword just before it, and it says, okay, that's not going to be a function call. I need to make this new shirt first, and then I need to apply these parameters back to the constructor. So then when we run output shirt, we pass in the shirt. This function echoes out the string, and we get large blue shirt because we passed in blue for the color and large for the size. So sometimes you want to be more specific with your types. Sometimes you want to give some more functionality to a class, but you might not have access to change it, or maybe you don't want to change the functionality. Maybe you still want that class. You just want some more functionality on a new one. Object-oriented programming lets us do this by extending classes. So our classes have a parent and child relationship. They can only have one parent, and they can only, or I guess they don't have children really. They can only have one parent. So this is kind of restricting because if I have a sweater that's a shirt, what happens if I have a sweater jumper? So now it's a shirt and now it's pants. I can't extend both shirt and pants. I would have to extend some common thing like clothing, and I'd have to re-implement all my shirt logic, and I'd have to re-implement all my sweater logic. So that's one of the downfalls of extending classes. So here in our sweater class, we've extended shirt. So what that means is that this class is already, because it extends shirt, it already gets all of the properties that shirt has. It already gets all of the functions that shirt has. But we can apply our own stuff on top of it. So here at the very top, we define a new property, material. We'll store our material there, like polyester or wool. We have a function. We override the get string function that we saw back on the shirt. Since we redefine this on this sweater class, we have to make sure that it matches that parent function, but we can change the functionality in it. So in this function, you can see that we get the color, we get the size, but now we also get the material. And instead of returning size, color, shirt, we now return size, color, material, sweater. We have a new construct method here. It's got 3 parameters now instead of 2. It used to be just color and size on the shirt object, but on our sweater, we also want to know what the material is. So we add a material parameter there. And you'll notice here at the bottom, we have a parent : construct call. That's very confusing. Parent always refers back to whichever class that your class extends. So when I say parent : underscore construct, What that's doing is it's applying the color and the size that my construct function gets to my parent's construct function. And therefore, I'm letting shirt manage what happens with color and size because I don't need to worry about that. Shirt knows all about color and size. So let's look at how this works with our output code. Um, you see, we're using the same exact output shirt function. It type hints against shirt still. We could just pass in our sweater and be confident that everything works. Because sweater is a shirt. Shirt isn't necessarily a sweater. Sweater is just a more specific version of shirt. So we can use sweater anywhere we can use shirt. So we just pass sweater straight into shirt. And instead of large blue shirt, we get large blue wool sweater. So let's move on to interfaces. The shirt thing was super successful. You sold a whole bunch of shirts. Maybe you got hired by a big clothing company. They want you to rewrite their stuff with their team. They want you to add some features. I don't know. Um, but maybe you're less interested in defining shirts and really thinking about what a shirt is. And you're more interested in outputting shirts or displaying shirts. Um, Interfaces are something that allows us to type hint just like classes, but they're not classes. They can't be made into an object. Only classes can be made into an object. As a developer, I can write an interface that describes the functions I need, and I can add it to my code base and have somebody else add the functionality later. So an example of that, let's look at this. So this is a clothing interface. It's got that same kind of shirt function on it, but instead, or that same kind of get string function from the shirt class, but instead we've called it clothing because that's a little bit more generic, and we'll probably want to get strings from pants too. So we just have a clothing interface here. Uh, you'll notice that there's no code within this get string function. The reason why is because interface never has any code. Any class that uses this interface will have to implement this get string. And since I can type in against it, if I have a class like this that is a clothing outputter with a single function on it, I can hint against clothing interface instead of clothing, instead of shirt. And then I can use that get string function and I can be sure that that's there. So with this, somebody passes in a shirt, somebody passes in pants, it's still gonna have that get string function as long as it implements that interface. So let's look at what implementing an interface looks like. This is a stupid simple class. Maybe this is something that you wrote up this clothing interface. You're like, yeah, this is going to be great. You hand it off to a junior developer. He comes back with this. This is fine. This is what interfaces are for. These kinds of really loose implementations will work with everything that I have as long as I'm using this clothing interface and I know that this get string function is there because I don't care what the implementation is. So let's say that now my code base, I have a clothing outputter, and I have like a basic pair of blue jeans that I can show on my site. I want to start selling it, so I pull in a simple store library, and this library is it's a modern library, so it provides a few interfaces for me to work with. Here's an example of an interface a library might show you. So our store library says anything that's a store item, it's going to have this get price function on it. And then it gives us some information about it in a documentation comment block. It tells us that it's going to return a float, tells us that if it returns 10.0, that's going to be $10. If it returns 9.58, that's going to be $9.58. So how do you use this to make your code better? Let's look back at these large blue jeans. We want to start selling these. So all we have to do is now implement this store item interface, and we just have to define this get price function and give it some kind of body. So in this example, we only had to change one line of code and add a single function that returns a number. And now all of a sudden, our large blue jeans work with everything that the store works with. Uh, we're in business now. Um, so sometimes you want to give something some extra type, some extra meaning without adding extra functionality. This is usually called like flags. You could just make an empty interface, and now any class that implements it declares itself. a member of that flag. So for example, interface tax exempt store item interface. Any store item that implements this interface, it doesn't have to add any functionality. All it has to do is say that it implements this. And then anywhere I want to make sure that something is tax exempt, I can just check if it implements this interface. So let's look at a cart interface we might get from this store the store package that we've included. We want to get a total. We want to get a list of items in a cart, and we want to be able to add items to the cart. Notice that there's nothing in here for things like taxation or I don't know. There's no taxation in here. That's something that is almost guaranteed to be needed. Um, but not defining it on the interface makes it so that your implementation can be much more flexible. So because cart doesn't need to care about any details about the taxation, all cart needs to know is the total and the items. That lets us be much more flexible with what we end up implementing, and lets us make a cart that has no taxes, a cart that has taxes, a cart that does anything. So sometimes you have some simple functionality in an interface that's going to need to be changed often. Um, Before traits, the only way to handle this with a class, uh, you'd have to have a simple class that implements the functions, and then you need to extend it. That sucks because you can only ever extend one class. So if I have existing code, um, think back to my genes. If I have an existing genes object that extends a class already, and I want to make it work with this code, I just can't because I can only ever extend one class. You can think of traits as the yang to the interface's yin. Interfaces list a bunch of structural things, but no actual code, just things that need to be implemented. Traits are just encapsulated functionality. They can't be made into objects, but you can use them in your classes and you can type in against them. So here's an example of a trait. Notice we don't have any interface implementations here. There's no way to implement an interface from a trait because that doesn't really make sense. You're never going to have anything. You're never going to have an object that is a trait and not also a class. So there's no reason why you would need to type hint an object against a trait and an interface. So they just don't allow that. Um, so we declare a few methods in this trait. The first one is called get items. You'll see it has a word abstract in front of it, and it has that semicolon at the end without any brackets. So it reminds us of the interface implementation. What abstract tells us is that any class that uses this trait, it's going to have to implement this get items function. So I know that if I get something that has or that uses this totaling store item list trait, I'm going to know that it has already implemented get items. So therefore, I can use that get items function within my own functions down below. Uh, so let's look at this next one, get total. This is part of the cart interface, and this matches the function signature for that. But it doesn't have that interface there. So if the interface changes, we'll have to make sure this changes too. Um, but we're able to implement this functionality here in this trait so that we can reuse it in our classes. And we'll see that in a second. This final method here at the end is just to abstract the process of getting the price from an item, and we'll look at that in a second. Um, but since taxing is a requirement for any store, we're going to need to implement taxing. But I think we can probably do this with a trait. So let's look at that. So this trait extends that last trait we saw. You can tell because it has a use statement right here. It says use totaling store item list trait. That tells PHP that this trait also includes everything on the previous trait. So since we already have that get total method, we don't have to define it anymore. All we can do is define this, all we have to do is define this protected function, get price for item, and then we can add some extra logic in there. And since going back to the previous one, since our get total calls that this get price for item, our extending trait can add all of its taxable functionality, all of its taxation stuff there. So now we've made our cart taxable with a flat rate. In this example, this property flat rate tax is just set to 1. And looking at this code, if that's set to 1.0, we multiply the price by 1, it's just going to stay the same. So this is just disabled by default. It's not going to do anything different. So let's implement a simple cart class. So this cart implements cart interface. So we have to define those methods. So we use this taxable totaling store item list trait, and that's that trait we just saw. That defines that defines the get total on the cart for us, so that we can manage taxing, we can manage totaling a cart. So we say that it uses this taxable totaling store item list trait, and all of our stuff is done. We're pretty much done. All we have to do is implement the get items and add items functions. But maybe get items and add item really isn't a member. Like maybe that's not something that should be part of the cart. That kind of seems like something that we could abstract and use later for maybe something like a list of store items. Uh, so let's move that into its own trait. So here we have a new trait, store item list trait. Pretty much all we do is copy out the get items and add items method and just put them into this trait. We change that property name to something a little bit longer and more obscure, store item list items. And the reason why we do that is because if somebody's using this trait and they already have a property on their class named items, our trait will use that property instead and cause problems. So using a longer name there and trying to make it so that it doesn't collide is probably smart. So then now that we've moved this, let's see what our cart class looks like. This looks ridiculous. We have no functions in here. We just have a use statement. We use the store item list trait. We use the taxable totaling store item list trait. Now we have taxation. We have a list of store items. We have everything we need in a cart. And all we have to do is define our tax rate, which we set to 1.5. So now we have a super solid implementation of a taxable cart. If we had a legacy cart that we were trying to update to this, all we'd have to do is use these traits, declare that it implements cart interface, and our legacy cart would be essentially done. It would be already implemented, even if it extends another class, which is important. Now you might be thinking, taxable totaling store item list traits doesn't exactly roll off the tongue. There's a lot of stuff, there's a lot of information in that class name that really shouldn't be there. So that gets us to namespaces. One thing namespaces lets us do is reduce how verbose we need to be with our class name. It lets us say less about our class. So in our example, taxable totaling store item list trait, we have quite a few different things in there, like we've got taxable, we got totaling, we got store item, we got list, and we got trait. These are all things that mean something different and all come together to make our class, but I don't think that they're really pertinent to the actual function of the class. So we can move all that stuff into the namespace. So let's look at our namespace trait. In this example, the first thing we define is the keyword namespace and acme \depot /store /item /list. One thing that we get with namespacing is the ability to prevent our classes from colliding with classes that we include from vendors. So the way that we do that is we include a vendor name and a package name in our namespace. In this example, our vendor is Acme and our package is Depot. So our effective namespace really starts at store. So notice that we now have to have a use statement outside of the trait. This use statement works a little bit differently than the use statement we looked at before. This one essentially says, since tax exempt interface is in a different namespace from ours, see our namespace is acme /depot /store /item /list. The tax exempt interface isn't in list, it's only an Acme Depot store item. So since it's not in the same namespace, we tell PHP that when we say tax exempt interface, really we mean Acme Depot store item tax exempt interface. So then later down in towards the bottom, we say if item instance of tax exempt item interface. PHP just knows to look in that namespace. Um, if we didn't include that use statement, you can see underneath our trait we have use totaling trait. We don't have a use statement for that class. What happens is PHP says, oh, there's no namespace for this class. They must mean that they want the class that's in the current namespace. And since we define the current namespace as Acme Depot Store Item List, and that's the same namespace that totaling trait will be under, it'll all just work fine. So let's go back to our cart and see what it looks like namespaced. Um, we use the two namespaces from before in the list namespace because now we're not in store item list, we're in Acme Depot store. So we use our list traits, and then we use something from our vendor. You can see our vendor doesn't start with Acme Depot. They have a different vendor and package. In this case, it's vendor is the vendor and store is the package. Uh, so when we say class cart implements cart interface, since we have this use statement here, the vendor store cart interface, and since we define our namespace, what we're really telling PHP is class Acme Depot store cart implements vendor store cart interface. And that all just works, and PHP is smart enough to know about that. Those namespaces with the class name, we call those fully qualified namespaces, fully qualified class names, and you could pretty much just use those interchangeably. You don't have to use these use statements. You can just use that fully qualified class name in place of the class name, and it'll all just work. So that's all I have for you. That's it. Um, I've not been watching the IRC. Looks like there has not been much in there. But I think I'm way over time. It's like 7 minutes. Um, so let's continue discussion in there. I'm not sure that I can bring anybody into this. I'm going to spend a little time trying to find a different way to present these so that we can actually engage verbally. I appreciate everybody watching. Please give me some feedback. Let me know if you have any questions at all. I'm happy to answer. So thanks, guys.